over infinity. Let me see if I can think of, if I have, what was it going to 0, wasn't it? That was one like we had a while ago, wasn't it? E to the x over x. Well, in this case, this is not L'Hopital because it's 1 divided by 0, right? The top goes to 1, the bottom goes to 0. Well, if so it's not L'Hopital there. This one is just 1. If you think about it here, the top's going to 1, but the bottom going to 0. Well, it's very similar to, if I just have 1 over x. It's very similar to that because the top's going to 1, so the top being 1 is basically the same thing. But yeah, the bottom going to 0, 1 over x, as x goes to 0, I guess I need to qualify it here a bit, right or left, because it would make a difference there. If I'm going from the right here of that, 0 from the right, this is going to just go to infinity. Because you've got 1 divided by basically smaller and smaller number, 1,000. 1 divided by 1,000,000, 10,000, whatever. 1 divided by, those are just going to keep getting bigger and bigger and bigger. Because 1 divided by that number, 1 divided by that number is going to be bigger than the previous one. So yeah, that's just going to be infinity. So if you have 1 divided by 0, something to that effect, that's infinity. What was that? What was that other one? It was basically the same. I think it. Oh, I don't remember what it was. But anyway, some of them, you just have. Oh, it was infinity divided by 0. Yeah, infinity divided by 0, same. If you have an infinity divided by 0, something in that form, well, that's going to go, again, infinity divided by something that gets smaller and smaller, that's just going to be infinity as well. Anyway, just wanted to make those points to you in case those come across those. Now, there are some others, though, that we need to talk about a little bit. There's a little more technique to it. Turns out some of them, we are going to need a little trick that, well, probably nowhere else you would have need of it. But here's a little fact here. You've got f times g. That can be rewritten as f divided by 1 over g. Now you might be asking, why in the world would you do that? Well, just sometimes you need to, and I'll show you. It turns out sometimes you need it for L'Hopital, to utilize L'Hopital. But anyway, just the fact that you can do that, let me establish that. Just take a look at this. F times g is the same as f divided by 1 over g. So I just took the f and divided it by 1 over that. That's what that happened. And you can do it the other way too. F times g, you say, well, it's g on top and then the bottom is okay. Those two are the same thing. Now, just to establish that, look at this. To see that those are equivalent, f times divided by 1 over g is the f. Doesn't that mean this? Which means f times what? Which is f times g. Okay. So it is true. Those are equivalent. Now, the question becomes, why would you do such a thing? Change this normal looking thing to something much more complex. Well, I'll show you why. Turns out that if you have an indeterminate product, 0 times infinity, we're going to utilize our little change right there, change f times g to something else. But it's 0 times infinity. Now, instead of 0 over 0, instead of infinity over infinity, we're going to have 0 times infinity. And the reason that's indeterminate is because that's not always going to be 0. Usually we think 0 times anything is 0. That's not always the case. It may very well be 0, but it is indeterminate. There's some issues, some things you have to look at to determine if it is. Let's take a look at that. Take a look at limit x approaches 0 from the right with x times L in x. Don't I have there 0 times infinity? Because this goes to 0. Obviously, it's x. So that goes to 0. And what does ln of x go to as x goes to 0 from the right? Well, again, if you have to, think about the graph. Here's ln of x. So as x, it goes to negative infinity, as a matter of fact, doesn't it? So that's what we're saying. This is an indeterminate product because I don't know. It may go to 0. It may go to something else. We just have to look at it. It's indeterminate. We don't know just by looking at it what it is, like some things we do. Okay? All right. So what we're going to do is we're going to utilize this right here. I'm going to take this f times g, and I'm going to rewrite it as f divided by 1 over g. And matter of fact, actually I'm going to use this one. Okay. Let's use that one. G divided by, in other words, I'm going to take the g, leave it up here. And then the bottom, so what would the bottom be? If I leave this one here, what's the bottom here? So it'll be 1 over 0. Okay? Now why would I do that? Well, notice now we have a L'Hopital. Because this is infinity, well, it's negative infinity. This 1 over x, if x goes to 0, what does that go? So I have infinity over infinity, or negative infinity over infinity. So I can do L'Hopital. By L'Hopital now, do the derivatives. So it's limit as x goes to 0 to the right, 1 over x. And then what about the derivative of that? So that would mean x to the minus 1. Would it be minus x to the minus 2? Or 1 over x squared minus 1 over x squared. Now the thing about this one is I can do a little simplifying here, right? Because that's the limit as x approaches 0 from the right, 1 over x, divided by negative 1 over x squared, or in other words, times x squared over 1, negative. Simplifying, that's just x, isn't it? Negative x. This simplifies to just be minus x. With me there? Cancellation. X goes into x squared, leaves me an x. Okay? So as x goes to 0, now I can say what that goes to. It goes to 0. So there is one instance where 0 times infinity is 0. Won't always be the case, though. Just note that. Okay? Let's try another. Limit as x approaches 0. X times the cotangent of 2x. Now this one, again, might be one, you might want to look at a little graph. Of course, x goes to 0, so x goes to 0. But what about the cotangent? What is the limit of cotangent x goes to 0? Cotangent 2x. Well, again, look at the graph. You need to. See, that would be 1 over tan 2x. So if you look at the graph of 1 over tan of 2x, refresh yourself there with that. I'll bring my calculator, but 1 over the tan of 2x. Just looking at x approaches 0. What does it look like here? Let's see, tan. Tan does this. And so flip that around. there'd be an asymptote there, so this would be typical of that. So is it like this? Other way. All right. Yeah, cotangent. Yeah. Now I remember. All right. So anyway, that's infinity, isn't it? As you go to 0, cotangent 2x goes to infinity. So we do have a 0 times infinity. And so the trick is, whenever we have that 0 times infinity, to do the f over 1 over g thing, or vice versa, g over 1 over. Which way do I want to go, you think? Well, let me just tell you here. Let's go the other way in this case. Let's leave this as on top, so the bottom would be what? 1 over cotangent 2x. Which also works out pretty well, because 1 over cotangent, wouldn't that be tangent? Which is just kind of, if you think about it, just kind of rewriting this anyway. But anyway, now what have I got? Well, this goes to 0. Tangent of 2x, so if we back up and do tangent of 2x graph, that's going to be the one like that. So as we approach 0, tangent approaches 0, doesn't it? So this is 0 over 0. What does that mean? L'Hopital. L'Hopital it. So derivative of the top is 1. Derivative of tangent of 2x, the chain rule, tangent is secant squared. Derivative of the inside would be 2. Now it's just really substitution. Because secant, what's secant of 0? Isn't that what this would be? Secant of 0? Secant squared of 0. Well, secant is the reciprocal of cosine. Cosine of 0 is 1, so secant is 0 is 1 as well, isn't it? So that's what I'm saying. 0 times infinity here is a half. It's not always 0. Okay. All right, so that's one thing. That's the trick. If you got 0 times infinity, that's what you have to do. You have to do the f over 1 over g thing, or vice versa. Okay? All right, here's another indeterminate form. What if we have an indeterminate difference, infinity minus infinity? Now, if we had infinity plus infinity, hey, that's no problem. I can spell. But if I have infinity minus infinity, zero? Maybe, maybe not. If it was infinity plus infinity, if we had something getting bigger and then we added something getting bigger to it, obviously that's going to be infinity. But infinity minus infinity, they don't always just cancel out and give you 0. So that's what we're saying. You have to do a little trickery here, or technique. Okay. Let's take a look at the limit as x approaches 0 from the right again. 1 over sine of x minus 1 over x. Which is infinity minus infinity, isn't it? Because this is 1 divided by something going to 0, and 1 divided by something going to 0 is infinity. 1 over x, same deal. 1 divided by something going to 0, that's infinity. So this is infinity minus infinity. Which might be 0, it might not be. We'll just have to see. The trick is, when you have infinity minus infinity, if you've got fractions, combine the fractions into 1. Combine into 1 fraction. And so this will be the limit as x goes to 0 from the right. If I combine them into 1 fraction, that would part. Multiply the first one by x over x, and then the second one by sine of x over sine of x. Know what I mean? So that would be the limit as x goes to 0 from the right, x over x sine x, minus sine of x over x sine x. So I can combine them now because I've got a common denominator. So that would be the limit as x goes to 0 from the right. It's x minus sine of x over x sine of x. Well, the good news here is, or the news here is, maybe not that great a news, but it is news. The news here is, what have I got? 0, 0, 0, 0. This is 0 over 0. Our old L'Hopital 0 over 0 L'Hopital applicable friend. Okay? I can L'Hopital it. So it becomes the limit as x approaches 0 from the right. Limit of that's 1. Limit of that is cosine. Derivative, sorry. Derivative of x is 1. Derivative of sine is cosine. Now what about the bottom? Got to use a product rule. First times the derivative of the second, plus the second times the derivative of the first. Now let's look at the limit as x approaches 0. That will go to 1. That will go to 1. To 0. That will go to 0 times 1. Oops. Not yet ready to. So this is 0. Bottom 0 still, isn't it? Bottom still 0. But we do L'Hopital once more, I think we've got it. Because I can do it again, L'Hopital. This is 0, 0. All right, so that'll be the limit as x approaches 0 from the right. Derivative of that 0, derivative of that's minus the sine, so it'll be positive sine x on top. Product rule again, once again on that, so it'll be first times the derivative of the second, plus the second times the derivative of the first, and then plus the derivative of sine is cosine. Now I think we're ready to evaluate because the top is 0, but the bottom is not 0 anymore. X times minus sine, well that's 0. Cosine is 1 as x goes to 0. So I've got 1 plus 1, so I've got 0 over 2. Hey, that's 0. Turns out this infinity minus infinity is 0. But don't be lulled into sleep on that. It's not always 0. It may not always be 0. But this one is. Is that okay?